start over. I'm going to start recording this so that way we can hear what I'm saying. So anybody who goes back and watches this can actually listen to me. Okay. So on Monday, so today and tomorrow is pretty much review. Hi, Nick. I know you're coming up. All right. It's good to see you, kid. On Monday, like I said, there's going to be 8 problems. It's going to be area stuff. And you're going to do 2 of them. So again, if your name goes from A through K, you'll do 1 and 2. You know, if you're L through N, then you'll do 3 and 4. The next set of people will do 5 and 6, and then 7 and 8. You will do the work right in front of me. And then there will be a place for you on Canvas. I'm going to have a place for you to submit it up on Canvas. Okay? Does that make sense? So that's how Mondays is going to work. And, you know, I'm going to see if you can potentially tilt your screens down. Like if, you know, you print out a copy of what it looks like, you can, or whatever. But I just want to make sure I can keep you honest. You're not allowed to use your notebooks. Like if you need to know formulas and stuff, they'll be on there. So the only thing you're going to need is paper and a calculator for this on Monday. And then you're going to show me your work. And then you're going to, if you're done, you're going to say, Seashore, I'm done. You'll take your pictures and you say, I submitted it up to Canvas, and then you can go. Okay? Awesome.
Will we have the opportunity to retake it?
Yeah, this one you will have an opportunity to retake. Or how about this? Any assessments we do, thank you for asking, Lucas. Any assessments we have here moving forward, typically the worst you're going to do is an M star. You're not going to get an I on it. You're going to get an M star, and then you're going to meet with me to fix it, you know, right then and there, and then we can kind of move on. So it's almost as if, I am going to make sure that you do wind up with an M. So if you don't wind up with an M immediately, you will eventually get the M. Okay? Yes? Everybody got that? Hi, Gabby. All right. So now that I've said that, let's go and do some math. Let me go share my screen, and over here, we'll share this guy right here, and that's not what I wanted. Let me unshare that. The wrong one. Let me go in here to workspace real quick. Okay, so now I can go to you guys. Thank you for your patience. Make sure, like I said, you have a notebook ready to go, and here it is. This is what I want to share. Okay, so we want to find, can everybody see my screen?
Yeah. Yes.
Okay, so we want to find the area of the shaded region, right? These little 4 pieces here in the regular octagon. And if you remember, I said regular, if a polygon is regular, what does that mean?
All the sides are equal?
Not just the size, but all of the
angles.
All the angles, good. So when we talk about a regular polygon, right, we have all sides and angles are equal. Angles are equal, okay? So when I'm looking at something like this, okay? When I'm looking at something like this, and what you guys could do is you don't have to sketch this out just yet. You can do it afterwards. But if it's a regular polygon, that means then, would you all agree that all of these sides here are congruent to each other?
Yeah.
Yes. Good. Yes. Right. So they're not just sides of a polygon. They also represent chords. They also represent chords. Who is the 32? Give me the significance of that 32.
It's the radius of the
It's the radius. Very good. That's going to help us, right? So there's a couple of things that we want to do here. If I had all of this shaded, right? If I had, let me just shade all of this just for fun for right now. If I shaded all 8, let's say that those are pieces of a crust of a pizza, right? And I wanted every piece, and I wanted all of those areas. How would I do it conceptually? How would I do it conceptually, Emily? What would I want to do first? Just conceptually before we do the math behind it.
Oh, my thing was off. I couldn't like hear you.
Can you hear me now? Can you hear me now, honey?
Yeah, now I can. Now I can.
Good. Okay, so I was saying, how would you conceptually find the area of the 8 pieces of crust around the pizza? Like before we do any math, conceptually, how would you tell somebody to do it? Like what would you want to find first?
Well, you know, there's 8 like sides, so you'd find the area of the octagon.
Okay, so we want to find the area of the octagon. I love that. And then?
And then, Well, since it's in a circle and like the spaces are open, wouldn't you want to find the area of the circle first and then like subtract?
See, and then after that, yes, I'm going to find the area of the circle, and then what am I going to subtract?
The area of the octagon.
Yes, that's exactly what we're going to do. So Harrison, if I want to find the area of the circle, because that's what Emily said we want to do, how do I get the area of the circle first, sweetie? What's the area of a circle, honey?
Pi r squared.
It is. And so who is r in this case?
32.
Good. So we're going to do pi times 32 squared. And if everybody wants to do that, so I'm thinking 32 squared gives me 1024 pi. So area is equal to 1024 pi. And I'm going to say leave it as 1024 pi because if we multiply out the pi, we're going to get a decimal, and I want to get as close to the exact answer as possible. So right now, we're just going to leave the area in terms of pi. Is everybody okay with that?
Yep.
All right, so the area, that's the area of the circle. Now, the more interesting area is finding the area of the octagon. Would you all agree with that?
Yeah.
Okay. Well, my thing is we don't know how to find the area of an octagon, but is there something that we can do? Can we break it down into things that we do know the area of?
Triangles.
Triangles, very good. So what I want to get everybody to do, or everybody to look over here, is that you're going to connect and you're going to draw this and you're going to break it down into 8 triangles. Okay, you're going to break this down into 8 triangles. And as we break this down into 8 triangles, here we go. What do you know about these triangles? First of all, what kind of triangles do you think they're going to be?
Equilateral.
I don't know if they're equilateral per se. I'm not going to go equilateral.
Isosceles.
Isosceles. Whoever said isosceles, I 100% agree. Would you agree that all of these segments, the length of all of these segments here, are all how much, everybody?
45 degrees.
32.
They're all 32 inches. Very good. So the length of the segments are all 32 inches. Now we'll talk about what the angles, what all the angles are. So that's 32, this is 32, going around, this is 32, and so forth. So all of those are 32. Now, I heard somebody say something. I'm getting back thing on someone. If you know if it's yours, can you mute your thing for me? Okay.
The 45 degrees. They're all 45 degrees.
What do you mean, up top here?
Yeah, right there.
How do you know that these angles in here are 45?
Because there's 8 triangles, and if you divide 360 by 8, you get 45.
Yes. Does everybody see how I just made a circle going around? Can somebody please mute their thing, because whoever's got that back thing going on, it's better. Okay. So knowing that this is a circle here, you can always find the measures of the angles in here. So my friend said, I believe it was Lucas, who said you're going to do 360 divided by 8 because there are 8 angles in here. And if we take 360 and divide 8 ways, we get 45 degrees for each one. Okay, is everybody okay with that? Hello? Okay, so now here's what I suggest we do. I suggest we take one of those octagons, one of those triangles out, right? Because I'm always a fan of taking things out and being like, okay, so I know that this is going to be 32, and I know that that's going to be 32, and I know that this is 45 degrees here. And so now if I can find the area of this, what am I going to multiply that by to get the total area of the octagon, everybody?
8.
8, very good. So now my first thing is how do we get the area of this thing? Like, what's one of the first things we need to do?
Find the length of the base.
Find the length of the base. What else do we need to find the length of? Can I find the length of the base right now?
No.
No, I can't find the length of the base yet. What's the first thing I'm going to have to do in this triangle then? I'm going to call on Gabby. Gabby, what's the first thing I'm going to have to do here in order for me to get the area of this triangle? Because we all know area is equal to 1/2 base times height, right? That's a triangle. So, Gabby, what am I going to do here, kid?
Oh, you could use trigonometry to find the other angle using the, to find the other side using the angle of 45. So
Okay,
you could,
what angle?
oh no, because it's not a right triangle, sorry.
So what can I make this into, like, can I do something so that I have
Yeah,
right
you could
triangles?
split it in half to make it into a right triangle, so that way we could use trigonometry to find the other side. So you would, like, from the point that your pen's at, you could bring it down.
What's
to
that
the
called? I am dropping in
altitude.
Altitude.
altitude. I'm going to drop an altitude. And what does it do to my two angles over here, everybody?
It splits them.
It splits it in half. So this is 22.5 and this is 22.5. So does everybody see I could take one of those triangles and go off to the side again, so that way I don't feel cramped. That's why I'm doing it. So I know that this is, I'm actually going to make it bigger just because I do feel cramped, because I write big, I write really big. Some people don't write as big as I do. Okay. So I am taking the right half. I'm taking that right triangle here. And that's 32 here. So now you guys know that if I look over here, I can call the altitude. What do you want to call the altitude, Sienna? What do you want to call it?
The height.
Okay, so I'll call it H. Good. What does somebody want to call this side over here? Julia, what would you like to call this side?
Oh.
Like why?
Sure. Okay, so over here, this is H, and then this is Y. I'll wait for you guys. How about this? If your last name goes from A through M, you're going to find H. And then anybody's last name N through S, you're going to find Y. Oh, this is delicious. Did anybody find Connor?
He said that he was doing a video with his, I don't know, but he doesn't see. Should I text him that it's okay to come like 20
Yeah,
minutes
tell
later?
him it's okay to get here. Tell him I'll let him in that the sooner he gets here, the better. Let me know when you've got H. Let me know when you've got Y. By the way, yeah, and if you're done finding H, go find Y while you're waiting, for those of you who are faster. And it doesn't matter. Some people work quicker than others, but that is quicker than others. So let's see. Sarah, do you have H?
Yeah, I do. It's 29.56.
29.66 or 56?
56.
And then for Y,
I got 27.137.
27.137. I'm going to say 27.14 then. Okay. So now we have our H and our Y. Does anybody have any questions on how we got those? Yes, no? Like if you wanted to get H, you use the cosine? Yes. Can somebody mute their thing?
Yeah.
That thing is killing me. Thank you. Okay, and then you would do the cosine for that one, and then you would just do the sine of 22.5 is equal to H over 32 to get your, to get Y over 32. Okay, so now that we want to get our area, we know then that if this is 27.14, then 27.14 times 2 is 54.28. So this is 54.28, and that represents the entire base of the triangle. Does everybody agree with that? Can I get a thumbs up? Okay, so now if I want to get the area of this triangle, Can everybody do me a favor and get me the area of just one of the triangles, knowing that my height is 29.56 and that my base is 54.28. Can you guys get me those areas? I'm going to call on one of you in about 18 seconds. Okay, Rachel, do you have the area, honey, of one triangle?
I just have to put it into the calculator.
Okay.
Um, 401.13.
What did you put into the calculator?
I put 27.14 and 29.56.
So I want you to look at the screen. So if I'm focused on this triangle here, the one that you see me focused on, yes?
Mm-hmm.
You found the
Yeah.
area of this, right?
Yeah.
So if you find the area of this, I want this whole area. So what would you do to your area?
I would multiply it by 2.
Yes, can you multiply it by 2? Because you found this, right, with this here, which is this right here. But I also want the other half because that represents this triangle right up here. Does that make sense?
So I got 802.26.
So 802.26, whoops, that's for one triangle, right? So that's 802.26 for one triangle. I'm gonna make that look better. My pen is 26. So now, Julia, what am I gonna do with that number?
You have to multiply it by 8.
Good. So if you multiply this by 8, that's gonna get us the area of the octagon. Is everybody okay with that? That if I do 802.26 and I multiply that times 8, I'm gonna get the area of my octagon. Is everybody all right with that? And you should get 6418.08. So that's the area of the octagon. That was a heck of a lot more work than it was finding the area of the circle, was it not, friends? Okay, so now I have, remember, my goal was to find the area of those 8 pieces of crust. And the first thing that we go back to, Emily said, you got to find the area of the circle, which we did. And then she said, you got to find the area of the octagon, which we did. So now, what am I going to do with those 2 things right there? Nick Canyon, what am I going to do? Where did Nick go? Huh. Nick, are you there? I see your head actually at the top there.
Hello.
Yeah, Nikki K. Did you fall asleep on me?
No, I didn't. Did you call me? I didn't hear you the first
Yeah,
time.
I said I wanted to find out what the area of the 8 pieces of crust are now, given that we know what the area of the circle is, and now we know what the area of the octagon is. We are simply going to?
You have to subtract the octagon's area from the circle's area.
Right, so we're going to do 1024 minus the 80, I think that's 6418, right? So we're actually doing 1024 pi minus 6418, right? That's supposed to be a 4, by the way. 108, and that's going to give me minus 1024 pi. Did everybody get 3201.07? Am I going too fast?
That's what I got.
Okay, that took care of the 8 slices. So it's going to take care of all of the 8 pieces of crust. If you remember, at the very beginning of this, I only had 4 of them highlighted. There were only 4 highlighted. Yes? There were only 4 highlighted. So what would I do with this value right here? What would I do? I'm going to call on Caitlin. what would I do then? If I only wanted the ones that I'm highlighting in yellow, that means how much of it do I actually want now?
Half.
You want half of it. So we would take this value here, right? And then we would divide that by 2. Is everybody okay with that? If I only wanted 4 pieces of crust?
Yep.
Divided by 2. And then your final answer should be 1,600. So it should be 1,600. Come on, my pen is just 1,600.54 would be the total area of those 4 pieces of crust, right? So for us, it was smart to find all of them, and then we're like, oh, hey, wait a minute, you know, it's all good. So what if I only had 3 of them highlighted? What would I do? What if,
Divided by 8 and then times 3.
right, so what if I had it where I only wanted these 3? How would you find it where it's just the shaded area of the green? How would you do just the shaded area of the green?
We would divide 3,201.07 by 3, or by 5.
Nope.
You divide it by 8
And then,
times 3.
yeah, so in other words, you would want to take the 3201. So think about this. You want to find out, you want to take the 3201, which represents all 8 pieces of crust, right? So let me see if I can find somewhere to write. Look at this, I have no room. Okay, so if I think about this, this represents the area of all of the pieces of crust. Is everybody with me? Hello?
Yes.
And if I divide that by 8, that means that I know what the area is for each piece of crust. So if I do 3201.07 and I divide that by 8, that means that each piece of crust represents 400 what is this? 0.13. So each one of these areas is 400.13. So in other words, I could just take that 400.13 and then multiply that by 3 to just get the area of the green pieces. Does everybody see that? Yes?
Yeah.
Good. So I think we have some time left. So we're going to go on to, I'm changing my mind on this one. And you guys are going to work on this one. You're going to start working on this one. We'll start it together. And then I think I'm going to make you finish it thereafter. But we're going to start on this one here. Noticing that I gave you the length of this. This is a regular pentagon. I guess I should say that. I didn't actually explicitly say that. So this is called a regular, this is, I should have said it's a regular pentagon. Regular pentagon. So this is 15. What's this, everybody? Just look up.
15.
15.
15.
15. All of these are 15, right? Hello?
Yeah. Yeah.
Okay.
Yeah.
So you know that those are all 15, right? And again, if you want to find the area of the shaded region, I know we have to find the area of the circle. We got to find the area of the pentagon and do some magic. Would everybody agree with that assessment?
Yeah.
Good. So now for those of you who are trying, who's trying to draw this? Who's trying to draw it? You are saying, I am. I'll show you what to do. Start with a circle. Okay? Start with a circle, and then you want to plot 1, 2, 3, 4, 5 points around the circle, and then you can play connect the dots, la 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 la, connect the dots, la 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 la. Okay? So that's definitely how you can go about when you're doing an inscribed polygon. Okay? All right. See that this problem is a little bit more complicated than the other one? Okay, I'm gonna let you guys just work. I'm gonna chill out here and I wanna see what you guys do. And I wanna see what you come up with before we say goodbye. Does anybody have to leave at 11:22?
I
Okay,
have to leave.
have to go back and watch. Anybody else can stay on, that would be great. Okay, so Sienna, I saw your hand up. We're gonna get started in the next couple of minutes. And then you'll just have to watch the tail end of this video to see where we go. Okay, honey? And whoever else had their hand up, I just only saw yours. Connor, thank you for coming.
I'm so sorry for being late.
It's okay. The fact that you got here means more than anything. Just try to get here on time. So if you are running late, it doesn't matter. If you don't show up, that's more bothersome for me than not coming at all. All right. Sienna, can I start with you and just tell me what you started doing?
I tried to separate it into kind of like triangles.
Good.
But it wasn't really working out for me. What I did was I just drew one on the side.
Did you, but
And then-
hold on, before you do that, just tell me, did you do this and break it down into 5 triangles?
Yes.
Awesome. So that's a great start. So now, is there something else before you go off to the side that you can fill out in here?
The center angles,
Good. And what are you going to do to get the center angles?
divide 360 by 5.
Yeah. And you got 72, is that right?
Yes.
Okay. So all of these angles are 72 degrees, right?
Yes.
Awesome. How many of you got that far? Can I get a thumbs up for people who got that far? Awesome. Good for you guys. So now you said you took one of your triangles and you went off to the side here, and you know that this is 15 here, right?
So I gotta go.
Whoever has to go, just go ahead. And just make sure you watch the rest of this, okay?
Okay.
All right. And we know that this is 70
Thank you.
degrees in here, right? And so, Sienna, if you have to go, it's okay. And then just come back and watch, okay, hun? Adriana, are you still here, hun? Is Adriana still here? No, it looks like, oh, look at what we're down to. Okay. So now, Anthony, good. There's Anthony. What am I going to do first here? By the way, what kind of a triangle, what kind of triangles do we create, everybody, when we break this down into 5 triangles? What kind of triangles are they?
Equilateral.
No, they are. If you
No.
look at this, is it possible?
Oh,
what kind?
isosceles.
Isosceles, good. And the reason why there are isosceles is because all of these segments are all what? These are all what in the circle? What are they all?
Oh, yeah, they're
All
all,
radii. And what's true about all radii in a circle?
they're all the same.
They're all the same. So we know that those are all equal. So now I can go over here and be like, okay, I've got myself an isosceles triangle. And it's not equilateral because this angle would have to be how many degrees if it was equilateral?
60.
It would have to be 60, and it's not. Okay, so now I want to find the area of this triangle. Harrison, what am I going to do first?
You have to find the height.
Yep, we got to find, so we have to drop the height first, don't we, right? So what that means, and when we do this,
Oh yeah, so you have to divide it in half with the altitude.
right in half. So therefore, what are the measures of these 2 angles going to be here? Julia, what do I got for my 2 angles up top?
36.
Equal to 36, good. And then Julia, down below, what happens to the 15, honey?
You have to divide it by 2, which is 7.5.
Love it. So that's going to be 7.5 and 7.5, right? Right. Everybody see we have a nice, we have a right triangle. We can take one of our right triangles out. right? We could take out one of our right triangles. If I do that, Nick, Lala, what is this down below, bud? What's this
Which
link?
angle? It's like laggy on my screen. I can't really see where you're pointing.
Really?
It's like jumping around.
Is it? How is that?
Like your like pointer. Like my thing's like laggy, so like it jumps around. I don't know. Where are you pointing? Like just.
I'm pointing. I'm pointing at the base of the right triangle. That's what I'm pointing at.
So 7.5.
Thank you. Good. See, you're a smart boy. I like it. Okay, so that's 7.5. We know that.
I just didn't know where you're pointing.
That's okay. And now we have to get the height. Is everybody ready to go get the height? Are you done already? Is that what you're? Lucas, what is that background? Are you going to tell me what the background is, or am I just going to guess what the background is? Oh, is that The Office? Is it The Office when they're interviewing? Oh, I love that. That's hysterical. I love it. Okay, so if I call on you, are you going to be able to give me the height? Sammy Stone, if I call on you, will you be able to give me the height?
All right, I didn't hear you. Yeah, I was just putting it into my calculator.
Okay, I'm waiting for you whenever you're ready, baby girl.
Okay, wait. 0.5. I got 2.8, or I got 2.71 for the height.
I got 2.71. What did you use for your equation for h?
I found, oh wait, I like mixed it up. I accidentally put 7.5 like on the side.
Okay, so what would your equation be? Just like, let's write out the equation.
So you're finding h, so you'd use tangent. So it'd be tangent of 36 equals x over, or equals x over 7.5.
Is it? So be careful. This is 36 degrees, right?
Oh, a 7.5 over x.
7.5 over 8. And I'm going to tell you what, I already knew. I didn't find h, but when you gave me 2 point whatever, I was like, I already know that's not the right answer. Can somebody say why they knew that? How many of you can be like, I know why Seashore knew that even before she did any math? How did she know that there's no way that h could be 2 point whatever? Lucas, what do you got, kid? You're on mute.
All right, so 7.5 is going to be the smallest side because it's the smallest angle.
Right, because this is 54 degrees over here, right? Remember, you guys, opposite the smallest side should be the opposite the medium side should be the medium angle. So therefore, h should be bigger than 7.5. 54 is bigger than 36, right? So that's always a way to know. If you're always remember that, guys. Does my answer make sense? So Sammy, do you have h for me now, sweetie?
Wait, my calculator gave me like a really small decimal, but I redid it, and then it gave me like 0.967.
How are you solving this?
I did 7.5 divided by tangent of 36.
Okay, go to mode on your calculator. Make sure you're in degrees.
Wait, hold on. I think I got it.
You go to mode, yeah, because you did it right. So did you put a parentheses around the tangent of 36?
Yeah, wait, 7.5
divided by the tangent of 36. You're right.
I don't know why it's doing that.
Go to mode on your calculator and make sure degrees is highlighted and not radians.
Tangent.
So you did 7.5 divided by the tangent of 36. You should have 10.32. Does everybody else have 10.32?
Yeah.
Okay. So now we know. All right, we're getting there. So this
Wait,
is 10 points.
that's,
You get 10.2, Sammy?
yeah, that's the height.
Yeah, that's your height. So that's what we found over here, which I know is over here. So now what do I do from this point on? Rachel, what's the next thing I'm going to do, kid?
The next thing you want to do is find the hypotenuse.
Do we need the hypotenuse?
No, we don't.
Because what are we trying to
So
do? Let's always go back to what our goal is.
we find the area of the triangle.
Do we have enough to find the area of the triangle now, honey?
Yes.
Good. So
We do area equals the base times height, and the base is 15, and we'd multiply that by what we just got, which is 10.32.
and then take your answer in. Remember, triangle's 1/2 base times height.
Mhm.
Right. So do we have the area of one triangle is 77.4? Do we have the area of one triangle of 77.4?
Yep.
Yes.
Yep.
So if I want the area of the pentagon, so my area of my pentagon, I'm going to take the area of my triangle and multiply it by 5. Yes, we're going to multiply that times 5. Awesome. Oh, and I'm going to go back to Rachel to what you said, that, we might actually need what you just said before. So mom stands corrected. So the area of the pentagon, did everybody get is 387?
Yep.
So Rachel, I'm going to go back to what you said a minute ago. And if I said to you, do we really need the hypotenuse? What should everybody in this room be saying to you?
Yes, we do.
Do I need to find the hypotenuse of the triangle?
Yeah, because you need the radius.
Yeah, the hypotenuse is the same thing as the
Radius.
Yes.
Radius.
You need the radius,
Oh my god, that makes so much more sense.
right? We totally need the radius. Like I dropped the ball on that. So Rachel, I stand corrected. We need the hypotenuse. Oops. So yeah, so let's go get the hypotenuse and we'll call that W for oops. Makes no sense. We're going to get ourselves a hypotenuse because that's going to be this guy right over there. That's a great problem. Problem's fabulous. Does somebody have the hypotenuse?
12.76.
It is 12.76. Awesome blossom. So this is equal to 12.76. So not only is it the hypotenuse, but we also know that this is the, say radius, everybody?
Radius.
Yeah, do we all agree that this is also the radius? Can I get a woohoo? Awesome. All right, so we know that's 12.76. So now we can find the area of the
Circle.
So this is the area of the pentagon. Can you guys get me the area of the circle, please? So now we know the area of the circle. We know that the radius, if I do area of the circle.
I got 80.2 for the area of the circle.
So that's going to be pi times 12.76 squared. Somebody shout that out again to me. What is it?
I got 80.2. Might be wrong.
2. Does that make sense? That can't be. There's no way it could be 80.2.
I got 511.
Yeah, you should have. And the reason why, Connor, because I'm already looking at 12.76 squared. I already know is bigger than somewhere between 144 and 169. I already know that. Do you know what I'm saying?
Where I went wrong with this.
You have to do 12.76 squared times pi. That's what you got to do first. All right. And Sarah, what did you get, honey?
511.51.
Fine. Lucas, do you agree with that?
Yes.
Did you even wait?
12. No, I see. All right, wait. I made a mistake. So
I got it.
what I
Well, I agree with Sarah because I literally just did the math on my calculator. Okay. All right. So
it's 5. Wait. If the radius is that the radius?
Yeah. Because this.
Are you sure? No, I think it is 511.51.
I know it is because look, this triangle here is this triangle over here, right? So when I
Yeah.
find you on the hypotenuse, then it's also the radius, and we said the radius was 12.76. 12.76
Yeah, so
pi is 511.51, right? So
yeah, that's what I said.
okay. So now so now we have to find the area of the, the shaded pieces. So the first thing I should do, number one, is, how many of you agree, subtract the area of the circle from the area of the pentagon to get the area of all 5 pieces. Can I get that out of the
Yeah.
I'll agree with that.
Yeah.
So this is going to be 511.51, and we're going to subtract that from 387, right? So if I subtract 387 from that, I get 124.51, right? And the 124.51 represents all 5 of these, all 5, yes? Hello?
Yep.
So now I only want 4 of them. So how would I go ahead and how would I calculate the area for 4 of them? Because remember,
Divide it by 5.
good. So you're going to divide it by 5. So if I take 124.51 and I divide it by 5, I get 24.9. So this is 24.9, the area of this. The area of this is 24.9. The area of this is 24.9. So Harry, what am I going to do? Just to get the area of 4 of them, I'm going to take 24.9 and
Times 4.
times 4. 24.9 times 4. And that will give me
99.6.
99.61. And that will be the area of 4 pieces of crust. Okay? Woo! I'm exhausted. All right. I thought that was fabulous. I think you guys did a great job. That would be something fun for you to go back and look at, because I can assure you that, am I going to give you something like this on Monday?
Probably.
I probably
Yep.
would. You're gonna see something like this. Okay. Wait a minute. Where did you? I didn't know. Wait, Juliana was still here. Gabby was still here, and Grace was still here. Well, I heard Connor's big mouth, so I knew he was. Yeah. Good. All right. So I'm going to stop recording. And again, I'm going to say to you, if you remember on Monday, you remember how the test is going to work on Monday. Can somebody repeat back what I said?
We're going to go in by letter of last name.
Okay.
Oh boy.
And you're going to get 2 problems. And then where are you going to post your work?
Canvas.
Beautiful. I will have a Canvas assignment. It'll be under assignments. And then you'll open it up. And then whatever those problems are will be the ones you'll do and submit to me. Okay?
Yeah.
Tomorrow, we're going to be going over that packet, that other stuff that I had you guys do. And then, so this is opportunity for review. I think you guys are amazing. And I want to thank you for a super fun morning. You guys rock. Okay? And that's it.